Cool. Hey, everyone. So we're going to be talking about the lean web tonight. Some ideas around building a simpler, faster World Wide Web. So with that in mind, I think the web is a bloated, over-engineered mess right now. And I believe that many of our modern best practices are actually making it worse. And what I want to explore tonight are some ideas on how to fix it, maybe a new set of best practices to replace what we do today. I'm Chris Ferdinandi. You can find me online at gomakethings.com. I'm known on the web as the vanilla JS guy. I didn't come up with the term, but I do spend a lot of time evangelizing the use of native JS methods and browser APIs instead of libraries and frameworks. So that means doing things like writing short guides and creating video courses. I run a project-based training program called the Vanilla JS Academy. Gonna teach students at a bunch of amazing companies. And in what's probably the highlight of my career, Apple actually used one of my open source vanilla JS plugins on their Swift website, which was particularly mind blowing for me because I don't have a computer science degree. Web development wasn't even my first career. I actually started as an HR guy. And then about 8 years ago, when I got completely sick of it, I taught myself how to code, transitioned into web development, and here I am. Really awesome career move. Highly recommend it. In retrospect, it feels like I made that transition at the perfect time. So about 8, 9, 10 years ago, browsers were finally standardizing features and implementations. So cross-browser compatibility was a lot easier than it had been even just a couple years before that. CSS3 and HTML5 were coming out. JavaScript's ES5 was out, which pulled tons of features, at least conceptually, from jQuery, and things that used to be really, really hard to do in like a cross-browser way were suddenly way easier. It was this like perfect sweet spot of powerful native features and ease of use. I look at the way things are today, the state of web development, and I feel like I wouldn't be have been able to make that same transition if I were trying to do it today. I'm not sure I'd be able to just teach myself and jump into it. It just feels bonkers to me, some of the things we do. Um, so I run a newsletter, a Vanilla.js newsletter. Every weekday, I send out a short email with code snippets, tools, techniques, and just random awesome stuff I find from around the web. And everyone who subscribes gets an email from me asking, what's your biggest challenge in web development? And I get back a ton of responses, but the one that I hear back more than anything else, it makes up at least 30% of the responses I get back, is some variation of my biggest challenge is keeping up. There's a good chance that some of you who are listening right now probably feel that same way. And the good news is there's a move towards simplicity starting to happen on the web. And that's what I want to talk about today. This idea called the lean web. I didn't come up with the term. Thomas Fuchs, whose name I actually had to ask him how to pronounce his last name because I always used to call him Thomas Fuchs. And I'm like, I don't think that's right. I should probably double check before I put him in a slide. But I really like this idea of the lean web as a way to describe a more simple, performant, and resilient approach to the web that puts the user first instead of us as developers. We don't have a ton of time tonight, but I am going to spend the first half-ish of the talk digging into modern best practices and why I think they're terrible. And then I'm going to spend the second-ish half of the talk exploring some new best practices that we might want to use to replace them. So without further ado, let's talk about why modern web development sucks. If I had to sum up modern web development in one sentence, it would be this: JavaScript, all the things. So much of web development is built around JavaScript. And at the heart of all that is JavaScript frameworks. They're listed on almost every front-end job description that I see. What framework did you use is a pretty common question when someone announces some awesome new project on Twitter. It's just kind of the thing you do now. So what's the appeal of these tools? Why are they so omnipresent in our industry? Honestly, they're pretty freaking cool. Like, I get it. One of the big attractions is around how they create user interfaces. So let's say you had some data about a user, some to-do items, whether they were completed or not, their username, some stuff like that. And you wanted to build a to-do app with a user interface around that data. You need an input field where people can add new to-dos. Maybe you want to list their to-do items, and if they're completed, you want them checked off with like a line through them. Um, you're going to need to add new to-do items, update them and like check them off as people complete them. Maybe you want a way for people to delete them. And you also need to account for things like what happens when someone has no to-do items at all. If you're using a traditional DOM manipulation approach, there's a lot you have to keep track of. You're constantly needing to check the current like state of the user interface before you make changes to make sure you don't mess stuff up. Like if there's no to-do items at all and you're going to add a to-do item, you also need to create the list that it goes into. Like there's just a lot of moving parts, and as apps get more complex, this becomes increasingly difficult to manage and more prone to error. That's where frameworks come in. They use an approach called state-based UI, where instead of worrying about what the user interface currently looks like at all, you spend all your time saying, based on these conditions in the data, this is what the UI should look like. You don't care what it looks like now. You just want to define how it should look under certain different conditions. So maybe if they have to-do items, you list them. If they don't, you show a message asking them to create one. If a to-do item is marked complete in the data, give it a special class. If it's not, don't. That sort of thing. And then whenever you need to update something, the user creates a new to-do item or whatever, you don't touch the UI at all. You update your data and the framework just kind of automatically figures it out for you, which is really, really awesome. It does all of that manual stuff you used to have to do behind the scenes under the hood, so you don't even have to think about it. And they're really smart, and they'll like diff the DOM so it's only updating that needs the things that need to change. And like they're pretty magical. I tried building my own, I built my own micro framework, and it was hard. These are masterpieces of engineering. And because established frameworks are used by thousands of developers at thousands of companies, you have more people testing code, finding bugs, pushing fixes. In theory, the code is more resilient. So you may be thinking, hey, that all makes sense and sounds really freaking good. What's wrong with this? Well, frameworks cause a lot of performance issues. These tools were designed by companies who deal with a level of UI complexity and scale that most of us will not. Most of the sites that we build don't have Facebook or Twitter-sized data bundles, and they hopefully don't have 10 or 20 nested divs to render a single favorite button. Like seriously, look at the Twitter UI. It is kind of a mess under the hood. And the engineering to accommodate that scale comes with a lot of weight. We like that frameworks have tons of bug fixes baked in, but many of them are for weird edge cases we'll never encounter and features we don't actually need. We're inheriting solutions to other people's problems, not ours. All of that JS that we load to solve problems we don't actually have has a huge impact on performance, particularly first page load, our users' first impression of our site or our app. Because of how browsers work, JavaScript is so much worse for performance than HTML or CSS. Adi Osmani wrote a really great article on why this is the case, titled "The Cost of JavaScript." And in it, he digs into kind of how JavaScript actually works under the hood. So, for example, JavaScript blocks page from rendering. It blocks other files from downloading. And it can't just be run after the browser receives it. As Adi explains, it needs to be parsed, compiled, executed. And there are a number of other steps that the rendering engine needs to complete. Browsers don't even just run through it after the first pass. They actually have to make 2 passes on the file to first determine what's going to happen before they execute it. And to just highlight how much worse for performance JavaScript is than HTML or CSS. Last year, Zach Leatherman tweeted asking, which has a better first meaningful paint time? An 8.5 megabyte HTML file containing every single one of his 27,000 plus tweets, or a React app with exactly 1 tweet on it? You can probably see where this is going. The 8.5 megabyte HTML file was actually faster by about 200 milliseconds, which doesn't sound like a lot, but it is perceivably faster. And it's more striking when you consider that the HTML file without any JS in it is 140 times bigger than the React version with just 1 tweet. And it still loads faster, which is just completely mind-blowing. There's another consequence of using tools like this: gatekeeping. JavaScript heavy workflows exclude people without JavaScript expertise from the process. And in my experience, people with deep specialized CSS expertise, for example, people that you really want involved in your process don't always have that same level of comfort or proficiency with JavaScript, nor do I think they should be expected to. These people have important essential contributions to make to the project, and they kind of get excluded. Alex Russell is a developer on the Google Chrome team. And in 2018, he wrote an article called The Developer Bait and Switch, where he talked about a straw man argument he often ends up running into with people when talking about frameworks. And it goes a little something like this. These tools let us move faster. And because we can iterate faster, we're delivering better experiences. And that ability to move faster and work better is probably true for some developers, but not everybody. So here's an example. That same year, 2018, accessibility consultant Rian Reitfeld resigned from her position as the WordPress accessibility tech lead. And she documented why in a pretty detailed article. The TLDR on this one is that at the time, WordPress was working on their new content editor, Gutenberg, built on React. And because it was built with React, and because neither Rian nor anyone on her team had React experience, and because they couldn't find any volunteers in the accessibility community who did, they couldn't effectively work on improvements themselves. Up to this point, if they caught accessibility bugs, they could fix them, push it into the code, and move on. This new world, they would have to file tickets with the developers who were frantically working to push features into the code and launch this thing. And so you can imagine what happens. A lot of these get pushed to the side. Fast forward a year later, May 2019. Gutenberg has been out for a month and a half, 2 months. A detailed accessibility audit is done on it and finds that there are, unsurprisingly, a lot of accessibility bugs. The report was 329 pages long and documented 91 accessibility-related bugs. Some of them really like simple low-hanging fruit that could have been easily fixed if Rian had been empowered to do her job better. So these tools may let some developers on your team work faster, but I'm not convinced that they're actually better for the overall development process or for your end users. There's another way we've attempted to get at this performance issue, single page apps. So with a single page app, the whole site or app exists in a single HTML file. JavaScript renders the content, handles URL routing, and so on. And these are nice in a sense because only the content refreshes. So theoretically, it's better for performance than having to re-download all of that JS from the frameworks and all the other stuff we're using on every page load. You download it once and then you just update the stuff that needs updating. But this also breaks a bunch of stuff the browsers just give you for free out of the box, which you then need to recreate with JavaScript. So for example, you need to intercept clicks on links and suppress them, figure out which HTML to show based on the URL, update the URL in the address bar without causing a page refresh, handle forward and backward button clicks, ignore right clicks, or figure out how to deal with those if someone wants to open it in a new tab, update the document title. Oh, and shift focus back up to the H1 heading so that screen reader users actually know where they are and aren't stuck at the bottom of the page, confused as all hell as to how they got there. This is all stuff that the browser just takes care of for you when you don't use a single page app. And this feels like a vicious cycle. We're literally breaking features the web gives you out of the box with JavaScript to fix performance issues created with JavaScript, and then re-implementing those features with even more JavaScript, all in the name of performance, which again, we ruined in the first place with all of the JavaScript. Like I said earlier, it just feels completely bonkers. And it's created this web that is incredibly fragile. We've all run into things like the white screen of death, or buttons that do nothing when you click them, or spinners that never stop spinning because the JS that powers the functionality or renders the markup never loads or breaks or has an error. And so things just kind of fall apart. And yeah, it's 2020. JavaScript's an integral part of the web. People don't disable it, but there are plenty of reasons why it breaks that are out of our control. CDNs fail. Back in July of 2019, a bad deploy took down Cloudflare, CDN provider used by 10% of Fortune 1000 companies. Some of you may be aware that that actually happened like literally a year later just a couple weeks ago. CDN, Cloudflare, same thing, took down a bunch of like really big sites, ruined a whole bunch of developers' days because they were getting tons of angry complaints from customers. Firewalls and ad blockers get overly aggressive with what they block. Files timeout. BuzzFeed finds that about 1% of all of their JS requests fail for some reason. That's 13 million requests a month. And people browsing on mobile devices while commuting go through tunnels and lose the internet. Maybe not so much these days, but generally speaking, in non-COVID times. And obviously, no one sets out to write code with bugs, but it happens. And when it does, JavaScript is the most fragile part of the stack. HTML and CSS, if they run into stuff they don't understand, they just ignore it and move on. But JavaScript fails spectacularly, and everything stops working. So with that in mind, let's look at a set of best practices, lean web principles that we can use to build a simpler, faster web. So the first principle is to embrace the platform. Rather than using dependencies or libraries, you can use native JavaScript methods and browser APIs that are baked right in for free whenever you can. So instead of jQuery, there's tons of awesome native JS stuff that does what we used to have to use libraries for before. Sometimes the platform provides HTML elements to handle stuff that would have otherwise required JavaScript. For example, the details and summary elements can create accordion elements. They're accessible, they can be styled, and they even emit an event hook you can hook into with JavaScript to extend them a bit. Similarly, CSS can handle a lot of stuff that we historically used to use JS for, animations in particular. Daniel Eden built an amazing library of CSS animations that you can poach from, just grabbing classes and toggling them as needed. Something that used to require a lot of JS to make work in a smooth and animated fashion, smooth scrolling to anchor links on the page. Today, single line of CSS can completely wipe out the need for a library there. I talked earlier about how single page apps or SPAs break so much of what the browser gives you out of the box just to recreate it with JavaScript. But there's another way to get fast page loads and remove that complexity. Multi-page apps. So the way we used to do it before SPAs were a thing. Each view of your app has its own HTML file, and you let the browser handle the routing for you. And you can still render HTML with JavaScript, but if you're using less code, if you're not depending on kind of more JavaScript and you're kind of offloading to browser native stuff, it kind of mitigates the need to use SPAs for performance issues. This approach is commonly called the Jamstack, which is an acronym for JavaScript APIs and pre-rendered markup. And it works really well when paired with service workers. One thing people love about SPAs is that if the internet connection drops, you can still use the app. Page loads feel instantaneous, but service workers give you those same benefits with more resilience and less developer complexity. You can pre-cache all of the files for an app if you want to and serve them locally, so they just load on click, but the browser still handles all the busy stuff for you. You can even cache API returns if you want to and load those from the service worker as well. Second lean web principle is to keep things small and modular. In our industry, we absolutely love tools that have lots of features and utilities baked in. We always go for the multi-purpose utility knife when sometimes all we really need is a pair of scissors. So, for example, the popular frameworks like Angular, React, Vue, they all include something called the virtual DOM to help with diffing. And that can really help with performance if you have a massive app with lots of nested elements in it. Most of the apps we build don't actually benefit from the virtual DOM, and in many cases are actually slower with it. There's a whole suite of micro frameworks that do the same thing as the bigger cousins at a fraction of the file size. Preact, 3 kilobyte alternative to React, same modern API. Vue has an alternative called Alpine.js. There's also Svelte, a precompiler that renders to 100% vanilla JS, and that's what gets served to the browser. The last lean web principle is that the web is for everyone. When responsive web design became a thing, we used to talk about how people browse the web on screens of all sizes. And somewhere along the way, we seem to have forgotten that not everyone has the latest iPhone, high-speed internet. We have no control over how people access our site. And the technology choices we make can prevent a lot of people from using the things we build. So I'd love to see us get back to progressive enhancement, building in layers. It doesn't have to be complicated. It doesn't mean you have to write your app twice, once on the server and once in the client. It can be as basic as just providing meaningful fallbacks. So let's say you wanted to use the GitHub API and some JS to show a list of your repositories on your site. Instead of an empty div, you can have a link to your GitHub profile. And then when the JS actually loads and runs, you can replace that with the list from the API. If for some reason that fails, people still have something usable. There's some resilience baked in. In many ways, the web is inclusive out of the box, and we ruin it with the choices we make. Each year, the accessibility organization WebAIM rubs a survey of the top 1,000,000 websites on the web. Both years they've run it, they found that sites that use frameworks have more accessibility issues than sites that don't. And that's not to say frameworks introduce accessibility issues, but something about the way we build with them, this tendency to just grab lots of third-party stuff and jam it in there, leads to this kind of developer over user kind of prioritization that I think is skewing the way we build. I struggle with accessibility too. The Accessibility Project is an awesome resource where you can find a ton of great tools on building more accessibly. I am over time, so I'm going to wrap this up. Very sorry. Just quickly to recap, the lean web principles are to embrace the platform, focus on small and modular tools over bigger ones whenever possible, and remember that the web is for everyone. This talk was an abridged version of a much longer talk and book that I've written. You can find all of that and dig deeper into any of these topics at gomakethings.com/JSLA. At this point, I will shut up and turn things back over to David. Thank you so much for your time.